This screencast is to show how to compile and use the software to compare DIC to DIC surfaces. It's built in Ubuntu 13.04. Here I have a fresh install of Ubuntu 13.04. The first thing we want to do is install the software required to compile and run the source code. So that is the LIB Insight Toolkit. I'm using version 3, that's what I built it with. VTK5, Boost libraries, Build Essential, CMake, and finally paraview for viewing the results. Alright, so now that that's done, I'm going to go into Firefox and go ahead and download the software. So if you go to my GitHub page, it's this one here. So go in there, and down in the lower right hand corner you can just download the zip. So we'll just go ahead and just open it, and I'm going to extract it to the desktop. So there it is there. So the first thing I'm going to do is compile the convert surfaces. This takes the surfaces from a .viz format, makes them into VTK format, and I'm going to put the binaries for that into a different folder from the source code. So going back to terminal, so once I'm in the directory where the binaries are going to go, I run cmake, the command ccmake, and then the path to the source code. So here I just press C to configure, it looks for all the components that are required, press C again, and then finally G to generate the make files. And from there, just type make. And there we go, it's all built. So if I, from here, just type in the name of the binary, it'll give me some instructions on how to use it. So we want the drop tower surface, the drop tower strains, instron surface, instron strains, and then the output folder where everything's going to go. So I'm going to make this permanently on top, and we're going to go back to these guys. So here's the surface strain for the drop tower, instron, surface, and strain. So let's go ahead and do that. Convert surfaces, and let's see, we want the drop tower surface. That in there. Now the drop tower strain. Instron surface. Oops. Instron strain. And I'll go on to the desktop. I'm just going to make a folder called surfaces, and we'll use that as the output. So now we should be able to go in here, and there are the two surfaces. So with paraview installed, should be able to open these surfaces. Kind of an odd thing here. It's because this guy is in a always on top mode. Let it go to the back. So there's the drop tower surface and the Instron surface. They're the two of the surfaces. So now that we have the two surfaces created, and here in the desktop surfaces folder, we're going to compile the software for comparing the strain. And there's two versions of the compare strain. There's this one, which is just compare strain, and then compare strain input transform. So this one, the first one, that's just compare strain, it does not take a command line or a transform on the command line to initialize the ICP, so you probably don't want to use that one. This one takes a command line option to initialize the ICP and is definitely more robust. So I would go ahead and compile that one. So I'm going to again make a folder for the binaries. Like that. We'll go back into here. And compare. Again, make run cmake. So again, pressing C to configure, G to generate, and then run make. So there we go, all built. Once again, we can take a look at this, and it gives a description of what's going on, and in the end it aborts it because I didn't give enough details on the input that we wanted. So it looks like this takes the receiver surface, the donor surface, output path, and then the initial transform. The initial transform, it describes down here, is given as a vector of 6 values: x, y, z translation, x, y, z rotation. And these are Euler angles. One thing to note about these Euler angles is if you don't give them, then the initial registration is done by aligning the centroids of the two surfaces. So in this case, I'm actually not going to provide an initial transform, and we're just going to go ahead and have a go at seeing if it'll work. So let's see here. Strain compare input transform. We want the receiver surface, which is typically the drop tower. So surfaces, the drop tower surface, and then we want the donor surface, typically the Instron, and then we want the output path, and we'll just go ahead and use surfaces again for that, and then the transform we're going to leave as blank. There we go, finished. So now we can go here, we get an output which gives all of the data, and you can see here point, strain, Instron, difference between the two, and x, y, z location. So this line contains what's going on, and then the commands that were passed. If we open paraview again and take a look at the surfaces, so we strain compare, we get this one. So this surface is going to be the Instron surface in the location of the Instron surface. So if I open the Instron, we'll see that they're basically coincident. I'll make this one yellow or some other color so you can see it. You can see there. And then if we open the drop tower surface, you'll see that it is off somewhere else in space. So the compared surface here, this guy, we can look, if we take a look at these. Let's see, rendered as a surface, and now I'm going to look at the difference in strain by mapping delta. Oops, I got here some sort of problem that's probably due to the fact I'm running this in a virtual machine rather than on a full desktop. So there you go. And from here you can, using paraview, you can save data. So we can save as a CSV file here. We can save all of this data for use in MATLAB, or if you don't want to do that, this StrainCompare.txt file can be easily read into MATLAB and give you again, the XYZ coordinates and the two strains and the difference between them can be directly read in.